I'm Jacob with Very Good Knife Company, and if you're new to the channel, welcome in. Been here a while, welcome back. Happy to have all of you. So, I've got some blades to profile. This was supposed to be my priority for the day. However, this morning I discovered that there was no dry ice at the store for Cryo. They said it might be there today. I held out all day. Did not happen. So, I do know somewhere else to get it now, but it'll have to wait until tomorrow. With that being said, I got to get all these blades profiled so I can get them ready for heat treat. And it'll be better on me to start heat treating in the mornings. Usually if I'm not entirely prepared for it, then it kind of puts me late in the afternoon because I will stay for the oven. It's storming pretty bad right now, so you might hear some of these. What's up, Fed Harrison? How's it going, bud? You might hear some of these styrofoam insulating panels up top talking and moving. Storming good. We're gonna get messy, do a bunch of grinding, a bunch of profile grinding. I've got 19 blades here. Only 2 are ADC RV2, so we're gonna go ahead and profile them first, and then I'm going to take them over to the bench and put them in layout die because I've got to grind them. Where do I put my mask again? I probably held off the live for 2 or 3 minutes trying to find my mask, and then I set it down instead of setting it on my cart. So this is what we've got to do today, and I'm just going to profile all of them, and it shouldn't take me too long. It's well, it's about 4:20, 4:30 now, so I got half an hour here, a little more than half an hour. All right, let's run it. What's up, Larry? So, what's up, everybody? Hope you're all doing all right. This is an interesting one. So this is actually an adventure. Little special. Has 2 inches of extra blade. That's what he wanted. Dan the Man Cho. And then I've got another special one here. This is a Tradition Junior in 5/32. So he wanted it a little thicker. I have been doing a good bit of little micro customizations like that, which I don't really have a problem doing. Here's some special ones. These are Ramblers with extended handles. This one actually got profiled already. So when I do these belong to Mr. John Wayne, when I do anything with extended handles, he usually does them in pairs. I'll do the first one, I'll cut it out and profile it, and then I'll use that one to mark the next one. That way I don't have to do the whole pulling the handle out and mark it the same way I did the first one. But here's a regular Rambler. It has not been profiled all the way yet. This one has not, and that's all they lack, is they've been cut out from the bandsaw. What's up, Randy? How's it going? Yash. I hope I didn't screw that up. What's up from Switzerland? How's it going, Switzerland? So you can see just a little bit of extension on the handle, about 1/2 inch. Mr. John has bear paws, and I mean massive bear paws. He makes extended. He has some extended handle Hornets and Wasps, and he makes them look like regular Wasps, like the Hornets. All right, good to hear. We've got one kind of like yours, Tradition Junior and ADCRV2, but this one is thicker. He wants them thick. That's what he wanted. So I'm going to take these 2 over right quick. So I have to, my goal is to get everything ready for heat treat. So I am going to wire wheel these 2 and get them in layout die. Right now they've got this little burr all the way around. It's kind of hard to see, but it'll cut the heck out of you. You can see it right there. And that's from grinding. I always grind one direction doing the profiling. And that burr will come right off. Plus this smooths out the edges, makes it easier to hold on to. And then I'll clean up one side if it's getting layout die on the side. If it's a full flat grind, doesn't need it. These are the only 2 that I'm doing this to. The rest of them, I'll show you how I wrap the Nitro V in foil also. But ADCRV2 can be done, the grinding can be done, or rough grinding, can be done before heat treat. At least mine is. And that gives us a differential heat treat. So now I'm just, what happened? Now I'm just going to use some layout die. Now this big extended adventure here is getting a full flat grind, so I don't need to mark the sides because our grind line is the spine. Don't want to go past it, we can go all the way up to it without a problem. Now this Tradition Junior is getting a hollow grind, which stops halfway up the blade, a little more than halfway. So I'll put some layout die on the side as well. Alright, we'll come back to those here in just a little bit, because I've got a bunch of other stuff to profile still. let's go do that. This time I'll bring the camera nice and close, so you should be able to see everything that I'm doing. Here we go. Get my mask on. Hearing protection. All the PPE. Oh yeah, here's another one of those special modifications. This is a 5-inch walkabout. What's up, Ron Crow? Here's a regular walkabout underneath it. 6-inch. This is a 5-inch. That's what he wants. Profile first. Start with the biggest. There we go. What's up, Gary? fun. Check it out. What's up, everybody? Let's see what we've got done so far. There's all our blades. There's 17 here. And now they all look like this, nice and rough. And they all have this little burr around the edge right now. So I've got to take them to the wire wheel and turn them into this, which is a more cleaned and refined look. So I'm sure you were probably wondering, if you were here most of the time, why I hit the little corners up front. What's up, Jeff? How's it going, bud? The reason why I hit these little corners is to keep the tip from being so sharp and puncturing the foil packets that I put them in. I learned that trick just from trial and error. It is kind of a pain in the neck when your blades are puncturing foil packets. Now, I don't ever grind past center, even though I never grind them super perfectly even. I never even go quite that far either. I just want them chamfered, that way the point isn't sharp, because it will, without even trying, it'll chew a hole right into the foil packet. Now, if you've stuck around, you've got just a minute before you see something even more cool than profiling, and that is grinding a couple blades. I'm doing a hollow grind, just one, and I'm also doing a flat grind. So right now what I'm doing is marking for center, actually scribe over center on both sides and create a double line. That's what that looks like. I have my wing dividers set up as scribes. They say, this one says 0.165. That's the thickness of this steel. It's 5/32. 165 doesn't equate to 5/32, but this steel comes oversized. And then I'll end up surface grinding it down to that 160 or 156, which is 5/32. See? Now this one is a full flat grind. Of course, it's still got layout die from Profile, but we don't need side grind lines for this guy. The spine is the grind line. We just need the center line. But this one we need some grind lines, because this one is getting a hollow grind, and it does not get ground all the way up. It's not a full hollow grind. Now, we've got our side lines and our center lines. These two blades right here are ADCR V2. So those, I actually do the rough grinding before heat treat. And given that it's an oil quench and these can be done by differential heat treat, it's not a big deal. In fact, If you were to ask me, it is a much preferred method because the differential heat treat is exactly what ADCR V2 needs for its peak performance. Most carbon steels are that way. Alright, I'm going to take my dust bucket. You saw me take my vacuum system out, my tube, my chute, the vacuum chute. I can't send sparks down into the vacuum chute because sometimes they'll catch on fire and they'll just sit there and smolder and burn holes in the vacuum line, which it is just about 4 foot of line here. Flex hose, the rest is hard lined. However, there is a section of flex hose outside where the grinder or where the vacuum is in the back room, and that's where it all likes to collect and catch fire, where I'm not out there watching it. Unfortunately, I know how that goes. So I'm going to make quick work of this one little hollow grind. This is a Tradition Junior in 5/32, so it's thicker than normal. Normal is 1/8 inch, and it still gets the hollow grind. This one is in 5/32. I'm going to clean the belt up on the edges. You can see all these little frayed, unclean edges. Ready? Don't blink. There's one pass. There's one side. Alright, here we go. One hollow grind. I'm going to hit this with a 120. That is my final finish before heat treat. Now after heat treat, I will take it back down to 60 in order to get the thickness exactly where I want it. And then I'll step it to 120, 220, and then 400, which is my final finish. But before heat treat, everything's got to be nice and chill. 120 grit. shoulder tampers. Take that burr off. There we go. Ready for heat treat. One, anyway. So, here is an ADCR V2 532nd stock Tradition Junior that has been hollow ground before your eyes. No jigs, no nothing. Just as free in the wind. Right down the middle. Both sides even on height. It's about as good as it gets. It's a beauty. Nothing like a nice, fresh hollow grind to me. I think they look great. Now, I don't carry hollow grinds. I actually despise them. I like flat grinds. I do carry a Tradition Junior though. And I think it is probably my favorite hollow ground knife of all time. Not that I don't think they're worthy. I just have found over the years that I do prefer the flat grind. It's just a little bit more versatile. So, this guy's ready for heat treat. We have one more to get ready for heat treat. Now, I will actually sneak these two into the kiln with a full rack of Nitro V. Now, my staging heat treat recipe, I have a my one run in the kiln. I'll have a staging stop. It'll hold at 1530 degrees, which is my heat treat temperature for ADCR V2. So I'll actually hold it for about 12 minutes, and that gives me a 7-minute soak time plus just a couple of minutes to quench whatever's hiding in there. Gives me a way to double heat treat. And then after that cycle, it'll continue, the kiln will continue from 1530 to almost 2000. It'll be about 1960. So that's pretty cool. Kind of boring, but cool. But that's the way I like to do heat treats if I'm able and have the room. I can't do like a full rack of ADCR V2 and a full rack of Nitro V. The rack only holds 6. Well, there's 6 slots. I'll fill it out, put a couple on the end, and sometimes I'll stack 2 together. Just depends. But still, can only get about oh, dude. What's up, Steven? I agree. Racks of ribs. We just did some ribs in the crock pot the other night ago. They're country style ribs, which, hell, you probably know what I'm talking about. And rib ends is what they are. We just put them in the crock pot and soften them all up. I don't need this dude. I don't know why I keep grabbing it. This dude's done. All right, now we've got a goofy 2-inch longer adventure. Pretty cool. It'll make a nice camp knife, but it's got to get full flat grind. That's what we're gonna do. Where we're at so far. Bring you a little closer. Look down. Maybe my face won't be in the way. Hopefully. Hopefully not. There we go. So here's a teachable moment. This is called grind warp. And you can see that it's pretty banana shaped right there. And what happens is certain steels will do it after heat treat, but most steels will do it before heat treat in soft form like this. This is an unheat treated piece of ADCR V2, and we're halfway through this grind. We haven't quite reached our center mark right there, and we also haven't reached a full flat just yet either. But it is heat warping, it's grind warping, and the best way to fix that is honestly to just keep on grinding. But when they're soft like this, you can straighten them out a little. I have heard a lot of controversy over people saying that steels don't do it. That's bull crap, because they do. But I will say this: if you're grind warping after heat treat, your blades are getting too hot. About as far up as I'm going to go on this guy. What angle and finishing grit for honing for a boning knife? Well, a boning knife should be super thin, and you're going to have to run it real slow so it doesn't grind warp like I was just talking about. Angle is subjective. It just depends on the knife. See how it warped? That's just from grinding, and this thing was straight as an arrow. What happens is you're applying pressure into the belt and heating it, and you're actually just stretching the steel as it's heating. It's just kind of bending around your pusher, and the best way to straighten these out is like this right here. You just come over to a table, a good solid table. This one's all beat up on the edge. Wonder why? And give it a little smack. And most of the time, how do I keep hitting things? Most of the time, they'll straighten all the way out. Now, this one's straightened all the way till here. See that? Now, sometimes you can bring them over to the vise and get them straightened back out a little. Again, if you're doing this with a heat-treated knife, you're going to snap it. If you're grind warping after heat treat, you've probably gone a little hot. That's it right there. She's nice and straight. Now, I could just not worry about it's you're expanding and heating one side. That's the key. Is you're heating one side. And the other side stays cold, and you're essentially expanding the metal around your pushing object. You're pushing into it. Wherever you're adding pressure, you're adding the most heat. If I'm pushing on this side, it's going to add the most heat right there where my fingers are. And now if you have something really wide to push with, it won't do it as bad. But for the most part, sometimes it'll still do it. But that's a little brighter so you can see that it's nice and straight now. Now, I could go back to the grinder at that stage and just grind through it, but sometimes it'll lead to that tip kind of going astray, in ways that you don't want it to go astray. So you can see it's not perfectly straight. There's a little bit down here in the handle. That I'm not worried about, because when I get done with the blade, I always give them a little smack. And they'll straighten right out, just like that. So, like I said, you could go to the grinder and try and grind that heat warp out, but if they're not heat treated yet, then you're okay to just bend it. Try on the other side. So, once you've ground both sides, it can be a little hard to tell what kind of heat warpage you have, because sometimes it'll warp out there on the tip. Where that's just where it keeps warping, is about the it's about where the grind breaks that spine and starts the distal taper all the way to the tip, and that's where it keeps wanting to warp. At this stage, if they're doing that, I will get them back to right before I finish doing the hand grinding process. That's all that one took. And it can be deceiving, because if you're looking at your tip there, and that layout die is kind of worn off already, got a little bit of that heat rust. But this side doesn't have quite as much. Let me look. This side right here is ground right to the line, and this side has a little bit more meat to grind off of the line. And if you're trying to straighten it out and you're not ground to the line on both sides, then you can fool yourself. But I always leave some up top and down on the center and the edge to hand grind it like this. Go. One side. See that little micro cheek? That's all for that one, for the 36th grid anyway. So, that's the only way to do it, dude. It is the only way. Now, I do like, you notice that I do like the rest platen to do the hogging out and get the majority of it off. And that's because the sparks themselves will burn your fingers to death on a flat grind. On the hollow grind, you know, I'm just going right up to the wheel and hogging into it. But there's not as much clearance down here between your finger and that belt. And when you're grinding off a whole bunch of material, it'll kind of, all those little shavings will build up and burn the living shit out of your fingers. So I like to get them, the flat grinds, really close to my final line, and then I will freehand up into the belt. It's another reason why I do that here. These platens on the back, they'll get all scooped out and all messed up, and so they're not perfectly flat anymore. This section from about right here to right here is still nice and flat. So I'll do the rough down here on the bottom, and then I'll move up above that and finish out. And that line gets way more crisp as you get into a more flat platen. Now, I don't finish grind on these ever. I never finish grind on this platen because this one does all my rough work, and it's almost guaranteed to be not perfectly flat. However, my other platen here, this one, I'll actually surface grind the plate pretty often. Every 100 knives or so, I'll surface grind that plate and clean it up, make sure it's nice and flat. That's what I do my finish grinding on. Because those plates will wear out so bad. Here, I've got one for you. This one, you can see the dip. See the dip in it? Now I could flip it over and use the other side, but it's actually got some tapered in cuts. I do surface grind my plates. There's nothing wrong with surface grinding the plate. Or are you talking about surface grind this one? Yeah, this one's got a ton of meat left on it still. Yes, I do surface grind my plates. And I just haven't done it with this one because this one got so bad. This one would actually be a better candidate to take to the mill with a fly cutter. You use a fly cutter, which is what you use to deck things like heads and stuff like that. But you'd use a fly cutter to cut the majority of this off, because I could go to town with a surface grinder and it would take me a lot of time to get this one back to super straight. But it's down here in the box. It's also really easy to make a new plate too. I do that often. I have a piece of bar stock mild steel that is this exact size, 2-inch width, and about 3/8 thick. That's what that piece right there is actually. And yeah, you can do it way more precise with a fly cutter for sure. The surface grinder is for micro adjustments, not major adjustments. All right, Yeah, that one definitely needs to go to the middle, which I no longer have. This plate that I'm using here is not quite that bad, but it has got some scoops in it down here at the platen, and they just get that way. You can switch the rest plate from the bottom of the arm to the top of the arm. I find that it puts me too high up. Plus, what happens is I can't use a cleaner part of the plate. I can only use this portion where I'm resting up here. There is no cleaner part of the plate. I'm all the way up. And I don't want to go under the plate because then I can't see what I'm grinding. That's why I always like mine down low. So I'll always wear them out the same way. All right. These have got to get, or this one has got to get a 120 grit. Not too worried about it with the 120. This belt is old and it doesn't have any grit left. Not throwing a whole lot. And I'm also grinding really light. There we go. There's our 120. See how nice and shiny it is versus the 36. And we'll run the other side. Alright. There we go. Do our little shoulder tampers. There we go. Man, chill out, Troy. There is our, so you can see how fast that ACR V2 rusts. I mean, literally, I just did this side. I just ground this side. And dipping it to cool it, and then grinding the other side, heated up that water on this side, and rusted before your eyes. It was bright and shiny like that. So, this guy is ground perfect right down the middle. Everything is nice and straight. You get a little bit of warpage right there in the middle. There we go. It's carbon steel, and there's also a bunch of rust enzymes in this water. And there you go. There you go. Now you never have to see me again, Troy. So this being carbon steel, it's prone to rusting anyway. It has a high carbon content, and it just does that anyway. But what's causing it to go faster, to rust faster, is I'm dipping it in a bucket full of rusty shavings. So there's a bunch of rust enzyme in there, and then I'm heating it up. So a lot of the surface rust, to tell you the truth, a lot of the surface rust that you're getting on them while grinding is a lot of those microparticles, these super fine microparticles that we're grinding off. That dust that you can hardly see, a lot of the surface rust is that, not necessarily the blade itself. Those little micro pieces mixed with water on one side plus a whole bunch of heat, that's enough to accelerate a massive amount of instantaneous oxidization. So right before your eyes you can watch it rust. Not to fear though, because if you finish it right, then yeah, that's sometimes the way they are. It can be that way. So these guys are actually going to get cleaned up. I'm going to clean them up right quick, and then I will show you two different ways that I prep two different steels for heat treat. Evapor rust works pretty dang good. It really does. I find that catching them before they get too rusty works the best. I know that's not always the case. I understand. I got rusty knives too. But it is what it is. It's alright. Not the end of the world. So I'm going to grab some acetone. I'm going to clean this layout dye off of them. Then it just comes right off like it wasn't ever there. I love acetone. Not at all. Alright. Damn, Troy, I don't know what happened there. I feel like we were jiving and then all of a sudden. Yeah, no dishwasher at all. So, I've made some high-end kitchen knives, some really, really high-end kitchen knives in my career, and have had people put them in the dishwasher despite us telling them not to. What would happen is you'd have these people leave out of town or something and have like maids and nannies and whatnot take care of their house or put their $2,000 kitchen knife in the dishwasher. I think I'd have a heart attack, honestly. If you haven't thought about, like, maybe just put it away before you leave. I mean, whatever. Yeah, legendary crash out. I don't know what happened. Like we were driving there for a minute, and thank you, sir. It's a hot one, but it's a good one. It's a good shot. I am thankful. It's a little out of organization right now, though. I gotta get my stuff back in order. The lack of organization that I have right now is killing me. Alright, so I'm just hitting these with a wire wheel. Take off a lot of that rust. You see, they haven't really rusted deep. And you can just kind of get rid of it. A care manual. I understand. I have to be good because this is my live stream, and it don't get shut down if I'm not good, but You didn't miss nothing. We were jiving. He was chilling, and everything was good. And then I got done with the 36 grit and went to a used 120, and he flipped his shit because I didn't put my eye protection back on for that 120. Now, I've probably done 50 or 60 live streams now. Maybe it's not quite that much. And only for like 1 or 2 of them have I done recently safety glasses. And I haven't worn safety glasses in a long time because, believe it or not, I've had more things go in my eye with safety glasses than without. And it's true. Steven said something about it last live stream or something, because I was wearing safety glasses and I went digging in my eye for something that got stuck in there. And he said something about like, I've watched you do all these live streams and haven't seen you dig in your eye yet with no safety glasses. This is just the way it is. I've had things bounce off of my safety glasses and go into my eye, do like a double, like bounce off the cheek, go into the safety glasses, and then into the eye. But anyway, on a wore out 120 grit belt that has no grit left to give, then it does, Bo. It really does. And I'll show you another thing that I do to my grinders to keep them. So you see this right here, that plate? My number one issues with these grinders is things will come right off of here and right into it'll kind of throw it right into your face. And this right here does more work than safety glasses, I guarantee it. And I got one on the other grinder too. And it kind of gets ground up right here because, you know, when I'm pulling down on the tensioner, it's touching. But I don't care. It's sacrificial, and it just doesn't like allow things to get to the face. Things still get to your face. And this is why I said I emphasize the 36 grit, 100 grit belt thing. Most of the time, what I get in my eye is not metal. It's just belt grit. Those are the things that go in my eye the most. 120 grit belts are slick as a whistle when they are used. They are slick. 36 grit, however, is not. Even when it's been wore out, there's still little pieces that come off. 100 grit, 120 grit, it doesn't happen. Things don't come off of that. Plus the dust and all that is really fine. So for finish grinding, my belt's usually running at a slower speed anyway, and I will not wear safety glasses because I can't see through the glasses when I need to see for grinding like down to 10 to 15 thousandths thick. You can't see that with safety glasses on. I can't anyway. Maybe I need to go and get my eyes fixed, but I have never been able to see with safety glasses, even really good ones. I've tried the shields with the mask, and I don't know. My next option is to spend like $2,000 on one of those what's it called, the Versa, 3M Versa. It's like this Predator mask with a hose that comes off the back of your neck, and then you wear this belt with a fan that feeds you constant clean air, the filtered air. The air comes from the box, and it's got its own filter, so there's no mask needed, and then the shield itself won't ever fog up because you're getting fed air. But these will fog up even with a lot of flow. And you see I have the nice ones with the protection to keep your keep stuff from like coming down into here. Yeah, it doesn't matter. It makes no difference at all. None. If it's gonna go into your eye, it's gonna go into your eye. See, they're already fogging up. You can see it. Look, they're already fogging up. So if I'm doing rough grinding, I'll wear them. But if I'm doing finish grinding with fine belts, sorry, Troy, you're just gonna have to shut me down, I guess. I don't. Shit. All right, so enough yabbing. I'm way behind, and I probably should go home. But I am going to show you a couple things first. One of them is how I do my heat treat prep for 80 CRV2. So you've seen heat treat prep all the way down to this point right here, which is 120 finish. The reason why I go to 120 before heat treat, the number one reason, all right, because I mentioned that once I go through heat treat, I will take them back to 60 grit in order to grind edge thickness. The number one reason why I go from 36 to 120 is because if you've ever seen anybody do like glass bottle cutting, you score the bottle, you'll score the glass with like a diamond cutter, okay? And then you'll heat that up and then you'll cool it. And that score creates its own crack and a separation. If you leave your blades like it, I like to grind them thin. This is about 30 thousandths at the edge right there. Now the final edge thickness for a Tradition Junior is about 15 thousandths. So I've still got a bunch to grind off here. At this thickness, I don't really have to worry about like wrinkling dragon's tail, any warpage at the edge. I just don't have to worry about with an anti-scale coating, and I'll show you that in a second. I just wanted to bring some light in here because the 120 grit brings it down to a smooth finish. The 36 grit will leave score lines. And where there are a bunch of deep scratches or score lines, you run the risk of chasing out one of those with a crack. Now, I have not cracked an 80 CRV2 blade, and honestly, I don't remember the last time. Somewhere in my early stages of trial and error, I have cracked some blades. 52-100s prone to cracking. Sometimes the lower carbons, like the 1070s, 1050s, they'll crack. Again, this all has to do with a lot of factors, but one factor that you can avoid that with is not leaving rough scratches on your blades. So if you were to take a knife after heat treat, when it's hardened, if you try to go from a 36 grit finish to a 120 finish, it'll shred that 120 because it's too much for the 120 to take off of, right? So you got to kind of step your belts out. So after heat treat, I want to take down edge thickness, right? The reason why I go back to a 60 is because the 120 doesn't cut aggressive or a fast enough cut. What it'll do instead with a heat treated blade is start heating that edge up, and we're going to ruin the heat treat that way. So I don't want that. I'll go back down to a 60 in order to aggressively remove material. Now, when I say aggressively remove material, it's a completely different feel than the pre-heat treat grinding. I'm not putting half as much pressure into it because I don't want to induce a whole bunch of heat. I want to keep my grinding cold after things have been heat treated. And that allows the 60 grit, a brand new 60 grit will last a long way. The Rockwell hardness on my 80 CRV2 is about 60.5, just on the high side of 60, which is pretty good and hard for 80 CRV2. You can actually get 80 CRV2 up to like 65 Rockwell, maybe even higher. Not that it's sustainable, or even there's no reason to get it there, but you can get it there heat treated just right. It sucks at that hardness, but so this is anti-scale coating, right? This is anti-scale coating. This is ATP 641. This stuff is about 80 bucks for this. Well, it's not quite that much. It's about 70 bucks for this quart, but you know, you can do a couple hundred knives with it. So I like to dunk my blades in. And then what I'll do is I'll tap my blade with the edge down, and all that excess will run off and create a bead. Do you see the bead? See that nice, perfectly uniform bead? So, where's my torch? I'll take my torch and give it a set. 60.5 is right where ADCR V2 should be. 59 to 60 is good. I like it just on the high side of 60. But you can see that bead cooling a little slower. That is all it needs to go in the kiln. So at this point, this blade will then go into the kiln. I put them in cold. I always put my ADCR V2 in cold. Always. There are people that, you know, I had this conversation with Alan, and I had this conversation with John, Heavyset John, and I've had this conversation with a few other people about whether or not to put the knives into the kiln hot or cold. I've tried it both ways, and I feel like the difference is marginal. It really is. However, I do think that the blades are more stable when you run them cold. You're not really shocking them by putting them in a hot kiln. So I have noticed less warpage with my carbon steel if I put them in cold. And when I say cold, I mean sub 1000 degrees. If I do a heat treat 20 minutes ago and the kiln's still cooling, I will crack the door just a little and I will let it cool down. I really like it to go down around that 500 mark. That's where I like it to be. And it doesn't take all that long to go from like 1530 down to 700-800, and then you can open the door all the way and put a fan out towards the front of the kiln just to get the air moving, not necessarily to blow into the kiln. That will crack your kiln bricks and ruin your elements. So you definitely don't want to go blowing inside of the kiln, but I mean, you can accelerate it. So I've used a brush because this is too long to get down in there. I just use a paintbrush to paint it on real thin, and before it dries all the way, I'll wipe off the paintbrush on the rim of the can, and I will take my paintbrush and create that bead once again. Now what this is doing is essentially creating a micro hamon. And so in my experience, when you're doing differential heat treats, the fastest piece of the knife to lose temperature, the edge will lose temperature. It'll drop temperature like a rock because it's so thin. Think about putting like a steel ball in the kiln, right? Put 3 of them in there. The smallest one is going to cool off fastest. That's kind of like a common knowledge, just a sensible kind of thing, right? You would think that the smallest one is going to cool off faster. So the thinnest part of this blade is going to cool off and lose the most temperature between the kiln and those quench tanks right there, which you notice are about 12 inches apart for a reason. I want to be, well, best gay YouTuber I've ever seen. Well, sorry to let the gay community down, but they can't have me. Anyway, this right here is what they'll look like with that little bead, and what that bead does is add a little bit more insulation at the edge in order for me to continue or to keep that heat. Now, there are other reasons for that to be there. What you'll get is a difference in speed of quench, right? And that's what would cause a hamon, right? So the difference, like on Japanese swords, you have a hamon, and that's an accentuated aspect of that blade, and they use something similar to ATP 641. It's more of a clay charcoal-y mixture. Look, I'm not a fucking scientist. I'm sorry, excuse me. I'm not a scientist on this stuff. It's getting late. This is what happens, isn't it, Steven? Steven knows what happens when I'm here past 5:30. I start letting words fly. So I don't know all the science. But I will say that the difference in speed of quench is what causes the hamon. And the difference in speed of quench causes different hardnesses, right? So ADCR V2 is what is called a fast quench steel. What that means is, in order for it to harden, it has to be quenched in a fast quench or a thin oil. So the thinner you're quenching liquid, or whatever you're quenching in, the thinner you're quenching liquid, the faster it will disperse heat. Water is obviously the king of that. Water disperses heat really fast. However, water disperses heat too fast. That is why you can't heat treat 90% of the steels out there. Thanks, Connor. That is why 90% of the you can block the quench with clay. Yeah, that's kind of like what I've got here. The ATP 641 is like an aluminum powder in water, though. It's not really a clay, but it does take the place of a clay. The reason for that is a higher temperature, right? So yes, the number one reason for the anti-scale coating on my ADCR V2 is surface deformations caused by oxygen. So ADCR V2 specifically likes to do an orange peel on the surface if you don't have some kind of coating. I learned this over a decade ago. I learned this about ADCR V2. It is very finicky without the anti-scale coating. So I never have any surface formations, any issues like that with it, with the anti-scale coating. It saves so much. Plus, that added bonus of being able to go just a little thinner on the edge. With the anti-scale coating, I can create that bead, right? You can see that bead, that little buildup right there. That gives me an insulator. What's up, Scab? How's it going, brother? Are you burning up down there? We've got Florida humidity up here. In fact, I've had people in Florida tell me that it's hotter up here than it is down in Florida most of the year. It's stupid hot up here right now. We're just talking about heat treats and blabbing. I was just explaining dude, it's ridiculous. I was just explaining the reason why I coat my ADCR V2 carbon steel blades in this ATP 641. My goodness. So it's essentially a form of differential. It is not a form. It is differential heat treating, and we're creating essentially a micro hamon. So now, I did talk to several people about this particular thing at Blade Show, and I was kind of taken aback because I I don't know, I just haven't done enough research, I guess. This guy that I talked to doesn't use foil for his stainless steel. He uses ATP 641 because it can go up to, let's see what the temperature says, temperature rating, doesn't say. I'm pretty sure it's 2100 on the ATP 641. I want to say 2100. But anyway, he uses ATP 641, no heat treating foil. My issue with that is if the coating itself is not perfectly even, then you will have spots that don't clamp the same, because these Nitro V blades go in between these two plates right here, which are super massively scientifically flat, right? So if it's not an evenly coated surface, then I'm worried that it won't quench exactly the way I want it to. However, I'm gonna give it a try just because I want to. I need to know. Tell you the truth, it would be awesome because this roll of foil here is $400. Where is my, I'm looking for my shears. I have lost my shears. How did I lose my shears? We'll find them. So the heat treating foil is $400. Oh boy, we've gotten goofy in here, haven't we? It's late. I don't know where my dang, I gotta find them. I have to find my shears, my foil cutting shears. There they are. I don't know why they're over here, but they're over here. We've gone hunting for things. So like the ADCR V2, Nitro V, well, steel in general, when you expose it to oxygen when it's really hot, it'll scale or have surface defects. There's other things that can happen. It can crack. Certain steels can crack just air cooling. So you want to protect them from air inside the kiln and outside the kiln as well. So the way to protect the blades inside the kiln at 2000 degrees is with foil. This foil is this is a 309. Yeah, you can. I mean, if you roll it into a joint, you don't need the aluminum foil anymore. It's a joint. But you know what? I don't know anything about that, so I should not speak on that stuff. Anyway, you can use this foil in place of that anti-scale coating. And I'm going to cut me a small piece. And I'm going to fold it in half like so. And I like to use my, where is my short roller? Boy, life is a mess right now. So I like to use my Kydex cutting table for this, but I'm gonna build myself a table just for this. I'm gonna use my Kydex table and this little aluminum rib that I have here, piece of aluminum angle. That's what I use to cut Kydex, because I can slide the Kydex under this guy, the whole sheet, and then just cut with a razor. That's the reasoning for this. But I'm just using that as a guide to get me a little bend, a nice uniform crease. I'm gonna go once, and then I'm gonna fold it one more time. Just like that. And now I like to use what's called a seam roller. This is a steel seam roller. Once, and it flattens it super perfectly flat, and no sitting there running your fingers up and down and cutting yourself. I don't know why I keep moving this. I shouldn't have moved it. It's got to stay there. All right, so I'll use my aluminum plates as a clamp and start a crease on the end like this. Crease. Now this goes twice as fast when I'm not trying to explain it. Just like that. Now you've got a sealed on one end packet. I'll leave one end open. And remember, I was talking earlier about chamfering the little corners of the tip. I do that because this foil punctures really easy. Even though it's very, very tough and very thick foil, 309 stainless steel foil, it punctures really easy. If it punctures after you've taken it out of the kiln, it's not a big deal. Sometimes you'll see things like that. I'll show you what I'm talking about here in just a second. So here you can see the end. This is the most important part to get, because up at the tip where it's thin, it's obviously a lot sharper. That's why I get those little corners. And now I can squeeze it here without it puncturing. It's not a big deal. But you can see where the end of the blade is. I've left enough on the end not to make a whole bunch of creases. I try not to anyway. But I'm going to leave about 1 inch long. And then just like the other end, clamp it once, start it, clamp it twice, finish it. This blade is now ready to go into the kiln, just like this. And like I was talking earlier, I do have a little bit of a staging cheat that I do with, if I have like 1 or 2 ADCR V2 blades, I will put them in and I will quench them at that staging hold, about 1530. These will come out of the kiln and go, they'll be super, super hot. I'll pull them out of the kiln, 1950 degrees, and stick them into the, use the tongs, stick them into the plates, and then we'll clamp them down. We'll clamp the plates down, and then I'll use compressed air to cool the blade. Now, you want a controlled quench. You don't want a massively rapid, mind-numbing speed quench. You want a controlled quench, which is why we use aluminum plates. As long as the plates are the same temperature, then everything is going to quench exactly the same on both sides. Aluminum is extremely heat and electrical conductive, obviously, which is why aluminum is used for things like power line wire and stuff like that. But it transfers heat very, very, very efficiently, so it will cool those blades off really fast. So there is some educational information today. You got an education on profiling, and you got an education on people losing their minds over me not wearing safety glasses again, and a little education on oxygen. And oh yeah, I was going to show you what happens when you get a little oxygen in to those foil packets as you quench. So here you have a blade that got a little bit of oxygen somewhere. This is a bit of a decarb, right? And decarb is not a big issue until a whole blade looks like that, like deeply, really deeply. And the decarb is a micro leach of carbon at the surface level, which is why you would see that little tiny bit of rust. See that little tiny bit of rust? Then this is a stainless blade. This is stainless. There's no such thing as a stainless. It just stains a little bit less than the rest. But anyway, so that is a minor decarb. I'm not worried about a decarb until the whole blade turns like a dark purple or even blue. Sometimes they'll turn black. Here's one with a tiny little bit of decarb up around the tip there. Shit. Oh boy. You gotta quit eating them Hawaiian cookies. That's my problem. So this is not a rust. This is just a coloration. This is where those foil packets would come together, right in the middle. And when you get one that is like super perfect sealed and no air ever gets in, like the foil packet doesn't puncture anywhere. What this is from is a little micro hole in the foil packet, most likely, considering the most decarb that I see is all around right here. That little dude right there is the culprit of the decarb. The decarb is a result of oxygen getting to your blade. And so if you were to go without any foil or any kind of oxygen prevention strategy like foil and the ATP 641, what would happen is your blade would begin to decarb at or before the austenization temp, which is quite high. So you'll decarb your blade really fast if there's no foil or anything like that. Now, a lot of these blades, these adventure blades, look exactly the same, okay? And I'll tell you why they all look like that is because when you use the tongs to reach into the kiln to grab the blade, sometimes you'll pinch right here, and that little bit, you can see it already trying. When it's 1960 degrees, it's easy to puncture it just a little. So the key there is that they do make vacuum annealing ovens. Yes. This isn't an annealing process. This is the opposite, though. This is a hardening. Annealing, though, it's the same thing with annealing. You don't want to decarb too much when you anneal, but usually annealing temperature is a lot lower than austenization, which is a quenching or a hardening cycle. But like ADCR V2, this is what the blades look like after they've been quenched, and it's really hard to tell, but there's a little bit of a difference in color where that bead is. This is a good looking blade, and with a long taper like that, so this is a little bit of that oxygen decarb. It's not a big deal. That right there will happen as you pull it out of the kiln. A lot of that stuff will flake off. But anyway, you can see the tip there. All those little hot spots that can puncture those foil packets, that's where you're seeing the decarb at, and that tells you what's happening there. You're getting some oxygen, so you want to be careful. Now, how can this translate to your final product of a knife? So if you have decarb in spots like this, it's not a big issue. When I said decarb is a micro surface leach of carbon at the surface level, that's what I mean. If you grind it enough, you can get rid of all of those, what is remaining in this particular section. Now, yeah, that's the point of the vacuum, is to solve the decarb. But those are quite the setup too, and a bit of an industrial leap. That is future goals one day. So decarb isn't too big of an issue, like I said, until it gets really deep. This, you see a little bit of a decarb on the edge here, and it does go from one side to what you can expect with a tiny bit of decarb in your blades if you don't end up grinding it all out. What'll happen is you have a portion of your stainless that is more rust prone. Believe it or not, even though the blade may be made of something extremely rust resistant, corrosion resistant. If you decarb it, it can still have corrosion issues. So that plays into the whole heat treating it right, and it won't do won't have as much corrosion issues anyway. So again, a proper heat treat can solve more than just edge retention, toughness, and corrosion resistance, things like that. A proper heat treat can do a lot for you. All right, guys. I have to get 5 more of these blades ready for the kiln, so I can just come in the morning after going and getting dry ice for my cryo, and get them started as soon as I walk in the door. I just want to be able to hit the button on the kiln, turn the oil heaters on for those 2 ADCRB2 blades in there, and get started right away. And that was supposed to be priority for the day, but there was no dry ice. So. Now what I'm looking for in terms of buddies to heat treat with is thickness. That's all I care about is thickness. I don't care how big the blades are or whatever. If they will fit in my plates, then we're gonna run them. As many as I can fit in the plates. So with the smaller knives like the Wasps, I can fit 4 wide. You step it up in size to like the Ramblers. Excuse me. Step it up in size to the Ramblers. You can run 3 wide, Adventures 3 wide in these plates. And these plates are about 7 inches wide by about 13 inches long. But the thickness matters because, again, we're quenching, or we're squeezing with plates. If I put in, it is another part of, I'll explain that here in just a second. It's actually pretty simple. I want the thickness the same because if I put a thinner blade in between 2 thicker blades, obviously with a hard aluminum plate, that center blade isn't even getting touched, just on the bottom end where it's laying. So all the thicknesses have just got to be the same. So cryogenic treatment. I'm not a metallurgist, and I don't claim to be an expert on all of this. I am just I'm an expert in my field of knife making, in terms of doing my heat treats. I do have my own recipes down to an expert level, but that by no means makes me a steel expert at all. And there is a whole degree for that and a whole study. But essentially what cryogenic treatment does is it converts what is left over. I don't know the names. Martensite. It would convert leftovers into what it does is it essentially continues the hardening process, and you end up with a tighter pattern or a tighter grain. So with Nitro V specifically, you can gain another 2 to 2.5 Rockwell with a cryo treatment. Now when you cryo treat stainless specifically, it has to be cryo treated very quickly after the quenching process, because it is essentially a continuation of that quenching process. So I'm not sure that I've done too many live streams on the heat treating, but I have done a few, and I've showed you where, like when I pull them out of the foil packet, they look exactly like this is pulled straight out of the foil packet before surface grinding. Here's the same knife, but it's been surface ground to 120. When you pull them out of the foil packet, this is what they look like. in this stage, even at room temperature, you can take and do this, and they will bend like butter. In fact, they'll bend easier than a non-heat treated softened blade. So basically with Cryo, what I'm looking to do with Cryo is to bring up the hardness even more. I'm trying to bring out the max or the best potential practical hardness as I can. I don't want to get like an unhealthy or unmatchable hard by going too fast of a quench. I don't want to pull them out of the kiln and put them in the Cryo. They got to go through the plate. They got to get cooled down. But anyway, Cryo treatment of certain steels is a continuation of the hardness process. For Nitro V, if you don't cryo treat within 10 minutes, it starts dropping off of potential hardness that you're able to get. The potential hardness, right? So the faster you get it into cryo after the quench, which means after the plates, the harder you're going to be able to get the blade. Of course, with all the steels, there is a maximum potential hardness, okay? What I want to do to bring out the best quality of the steel is to bring it up to the fastest healthy quench that I can get, right? I don't want to be taking hot blades and sticking them in water just because the faster they cool off, the better. There's a balance, right? So the plates will take off all of that temp. Most of the time when I pull them out of the plates, they are sub 200 degrees. They're done. They're cold. And sometimes they're around that 200 to 300 degree mark, and they're a little hard to hold. But I will pull them right out of the plates, and I'll cut the foil packet off, and I'll go stick them right in a bucket and get them cooling really quick. So what I have found is the faster that I get, I know you heard me say the faster you get them cooled off, but that balance of healthy, right? So remember I was talking about the heat warpage earlier. You want an even cool down or an even heat, because heat on one side can make it warp. Well, that's what happens with them. So if you put them when they're too hot into the cryo, they'll start warping. Sometimes they'll warp in cryo anyway. In fact, if they're going to warp after the quench, it's going to be in cryo, because you can straighten them out. Like once you pull them out of the plates and they're in this form, they're all that gummy that I was telling you about. They're hardened, but there's a stage there where they have not cooled completely and solidified yet. They're hard, but they're gummy, right? And that is where you're going to be straightening them out. I'll take and I mean literally with this much pressure is all it takes. Sometimes they get a little more stubborn. I'll put them in the vise and just do the same kind of process that I was doing earlier, just to get them as straight as I can possibly get them. But I also noticed that if I take them too warm and put them in the cryo, then they warp really fast and they'll warp really bad. So I'll cool them quickly but slowly. I'll do them in stages. So they go to the plate first, they come out, they're around that 200. Sometimes they're not even that. They're way colder. And then I'll wash them around in the water and get them cooled off even more. I want them as cold as I can possibly get them before I put them into the cryo. So my cryo, what we're looking for in cryo is a minimum of minus 95 Fahrenheit. We want a minimum of minus 95. I use a bucket with a insulated cup. That's a Yeti cup. And then more insulation just to keep it cold in there. But what I do is I use a dry ice slurry, and if you mix it just right, you can achieve that minus 101, minus 100, well over that minus 95 that we need. We really need to get that 94, 95 to get the maximum cryo effect, right? So Dry ice is capable of much colder than that, or I mean, not. Liquid nitrogen is capable of much colder than that. However, it's not as easy to get a hold of. I will get set up with a liquid nitrogen cryo tank, but I have to have somewhere dedicated to do it. As some of you may know, dry ice, or I keep saying dry ice, liquid nitrogen can be a little bit dangerous. So if I'm able to get the temperatures that I need with the dry ice, then I will use the dry ice. It's not a big deal. The key here is that I'm actually getting them down to that minus 90 to 95 temperature. Dry ice and alcohol. 90% or better alcohol, because alcohol does not freeze. So I have a whole stash of alcohol in here. So I'll actually crush the blocks of dry ice up. I use my little wrench right here. It's flat, and I'll use this to crush the dry ice up into a powder, as close to powder as I can get it. And I'll just work it around. And I usually do this right before the blades are ready for quench. I'll go ahead and make my dry ice slurry. Yeah, it is very that's a good idea. That's a good idea. I need to just put dry ice and alcohol in that cooler over there. You know what though? What would happen is I'd end up evaporating that slurry and alcohol into the air, and it might kill me, or I'd catch a spark and blow the whole damn place up on live stream. That'd be funny, wouldn't it? Anyway, with the dry ice and alcohol slurry, the key with that is to not let it boil too much. It's gonna boil, there's nothing you can do. But the more it rages and boils, the faster it loses temperature. Dry ice does not melt, it evaporates. In fact, you just leave it in the styrofoam cooler, and it will just cease to exist in about 10, 12, sometimes 24 hours. It just ceases to exist. It evaporates and dissolves. No trace of nothing melted left behind. It's not like melting water ice. It's a gas. So, with the slurry, we want to get a nice, like the slush that's on the side of the road after it snows. That's kind of what we want, where it's soft enough to conform around blades when you stick something down in it, but not wet and boiling. So I'll put a bunch of powder in my cup, and I've got my big giant super powerful drill, and I put my I have a paddle mixer, a little tiny one that I use for my, where'd you go? ATP 641. Now I'm not seeing it. I cannot see it there. It's rolled away from me. So I have a tiny paddle mixer, and I'm trying to find it. But you guys know what I'm talking about. And it goes on the end of a drill, and I use it to mix up those little cups of ATP 641, those little quarts. So that's about the size it is. And it's just deep enough to get down inside of my dry ice cup. So I will slowly add alcohol until I have, add alcohol to the powdered dry ice until I have the consistency that I want. Now, the key to cryo is that it just has to get down to that 95 minus 95 Fahrenheit temperature. It just has to get there. It's not like an austenization temp and the soak temp for ADCR V2 is 1535. It must soak for 7 minutes at least. at minimum 7 minutes, because there's a transformation that happens. Cryo's not like that. It just has to get down to that temp. Yeah, it doesn't have to hold. But given that dry ice is not as cold as liquid nitrogen, which liquid nitrogen cryo treatments you can do in 15 minutes, and that's with a soak and hold. All we're really trying to do there is to make sure that the coldness penetrates the steel and doesn't just get the outside layer of the steel, like the outside surface. We want to make sure that it really soaks in. Once it gets to that temperature, it's not so crucial that it does sit and soak. It's not as crucial as the austenization soak, where things absolutely have to transform. You can't just get it red hot and dunk it in oil. There's a transformation that has to happen within those 7 minutes. It just has to be that way. Now, of course, at high temps, the longer you let it set, then you start going backwards. You'll start having other issues. But with the cryo, it's just going to get colder. And once it's there, it's set with cryo. If it's warped at all and it warps in cryo, it's that way. You can plate them, clamp them, you can counterbend them. I have a few methods to straighten them out. But sometimes you end up with some blades that just don't straighten. And I had a nice carbide tipped hammer. I don't know where it went because I haven't used it in so long. But this guy, you might not be able to tell, but it's warped. It's warped enough that I won't put it on the table. I just don't want to sell it. But this is a Nitro V walkabout that was going to be a Gen 3. It's actually thinner than 3/16 right now because I did try and grind as much of it as possible out and get it straighter. Here it sits, and it'll probably end up in my private collection because I can't sell it like that. I can't. Now, minor micro warpages, a lot of them will come out with grinding. If you're skilled enough, you can get them out with grinding. And still have everything centered up. It's okay. It's not a big deal. But when they're warped from pommel to point like that, that's a no-go. I can't do that. So you can fix that in theory, and it can be done because I've done it. But you can fix it with a carbide-tipped hammer. It has to be harder than the steel. So the Nitro V, after its entirety, after what's it called? Excuse me. Tempering. After its temper, which temper happens after cryo. So we really want to bring the steel to its maximum potential hardness to get the best out of it. And then the best way to get it where we want is to temper it to where we want. So tempering temperature will give us exactly what we want out of it in the end, depending on where we land that tempering temperature. But after all that is done, the hardness on the Nitro V is about 62.5. So it's hard. It's really hard. And you need something like carbide, a carbide tipped hammer. And what you can do is you can gently tap on the steel on the warped blade. You can tap on the inside of the curve wherever the warp is, and you can actually displace with that carbide tip. You can displace the steel in very, very tedious and microscopic amounts, and bend it back. It's possible. It's doable. Is that the way? Should it be done like that? It can. What's going to happen is you're going to have a bunch of little ping marks. I'll show you here in just a second. You can take a blade that's warped and you can straighten it out in tempering. Here's the thing though. So in tempering, you have what's called a transformation cycle. Your very first temper The very first heat cycle, the tempering cycle, after the quench, after cryo, after everything, your first tempering cycle is called the transformation cycle. All right? And that is where everything else that you're trying to uniform and everything else that you're trying to convert, the leftover austenite, martensite, whatever the hell it is in your steel, whatever you're trying to convert and get into its final form, that's when it's going to transform, is that the first drawback. So after your first transformation cycle, your second one would be a hardness drawback as well. You would be more focused on that because all of that special stuff happens in that first one. So if you want to straighten a blade out like this one, you can see it from this end pretty good. She warped. If you want to straighten a blade out, you must do it in the first tempering cycle, period, end of story. After that, it's not happening. You can try, it won't happen. But I have a couple methods. One method that you can do is to, let's go and grab this. One method that you can do is to use aluminum blocks like this. See, this one I've used for testing etches and stuff too. But you can take this block. Again, this has to be done in the transformation cycle. Right here you can see how warped this blade is. See how warped it is? I hold it down here flat and it's way off up top. And then if I was to flip it over, there's a gap in the center. Hear that space? So the warpage has a lot to do with your prep. If you put one of these blades in right out of the plates around that 150 degree when they're still hot, you'll put them in that dry ice and they will just steam up like crazy. The temperature difference is ridiculous and it'll make all kinds of violent little noises and steam out, make all kinds of smoke, and it looks cool, sounds cool, but what you're doing is shocking the blade. When you shock the blade, it's going to warp. So the less you are able to shock a blade, the less prone it is to warpage, which is why I pull them out of the plates and then I take them to the water to try and ease that temperature difference between what they are now and what they're about to go into. I just want to try and bridge that gap just a little bit. Ideally, so here's another thing that I've been experimenting with. So I'll put some of my extra aluminum plates, these two specifically, in the freezer, in the fridge freezer in there, and in about an hour they're about as cold as they're gonna get. So aluminum will soak up all of its outside temperature and acclimate to that temperature very, very, very quickly. So I originally started doing that to cool my quenching plates. These are my quenching plates. I do use these as quenching plates as well, but these ones are in the vise, and those ones are mounted up and ready for it. Wherever my clamp is. So I was originally using them to cool the plates in between quenches. So I would do a quenching. I would have 6 blades in here. I can only fit 3 in the plates. I'll quench 3. It only takes about a minute and a half to do that. I'll pull them out, get them cooled off as quick as possible and into the cryo. If I'm fast enough, sometimes I'll just set them aside. And, like I said, you got about to that 10-minute mark before you start dropping off hardcore what you're able to achieve as far as a max peak hardness. But as long as I'm inside that, I really like that 5-minute range just to play it safe. But I was originally using these. I would stick them in between the plates here and cool these plates, because these plates will suck all the heat out of the blades. And then I was using cold plates to try and suck all the heat out of the plates, right? That way I'd have my plates a little closer to, and there's not like a magic temperature that your plates need to be. They just can't be hot, because then your aluminum has already absorbed a bunch of heat. It's not going to absorb it fast enough for the next round if it's too hot. So if I'm doing a bunch of thinner, smaller blades like the Wasps and the Ramblers, even with 4 of these guys in the plate, they're 1/8 inch and they're only 6.5 inches long, and the handles have got some relief. I mean, within 30 to 40 seconds, they're handleable with your bare hands inside those plates. I mean, it happens really fast. But things like that Walkabout 3/16 steel, that's a little more than 11 inches long. I can only get 2 of these guys in the plate comfortably, and they heat the plates up way fast. So if I'm doing anything like that, I don't want to do it first. I want to do the smaller, thinner blades. Conservation of energy, that's right. I want to do the thinner stuff first. But anyway, one way that you can, I got sidetracked again. I wonder if you guys ever hear anything, what you wanted to hear, or if you just got an education on something else, because I got sidetracked. Anyway, another way you can alleviate the warpage is by clamping them to an aluminum plate. Now this works like a charm. If you have something that is warped pretty bad, sometimes you can clamp it to a nice aluminum plate. Now, here's my issue with this, okay? I am not the biggest fan of aluminum plate quenching for the drawback or the tempering, because that big giant block of aluminum right there will absorb so much heat, right? Now, obviously, you leave it set in there long enough and it'll all acclimate to the same temperature, right? But what happens is you end up getting that that heat on one side and cold on the other issue. And I've actually seen them. Nope, I cut them myself. That was actually what I started today's live stream with. So when this live stream ends, Kyle, if you go back all the way back to the beginning, you can see how I do all that. And that's what I did first today. With all of I did 19 blades today, and this is what most of them look like right now. And they were all just bar stock a little while ago. Once this live stream uploads fully after I'm done, then you can go back and watch it. But anyway, what I prefer to do over the aluminum block is what's called a counterbender. This is called a counterbender, and sometimes it's not as, I'll be totally honest with you guys, and this is not, there's no cap here, I've been calling this rig the strip club for years and years and years, because I heard an old knife maker call it that. Alright? This I call the strip club. If you got one that comes out a little bit crooked, a little bit a little not straight, you take them to the strip club. And if everything goes right, they'll come out maybe a little straighter than they went in. And in some cases, sometimes they come out a little more crooked than they went in. But I use a counterbender with this clamp. See this clamp right here? And I'll look down this blade, and I will actually bend it to the same, about the same amount of bend that it is warped. I'll bend it inward the other way. And again, that has to be done on its first cycle. I will leave it like that, and then let it cool like that. And then when you pull it out, 9.9 times out of 10, if it's done right, then It'll come out straight. Just the way it is. But anyway, oh boy, I hope I haven't bored you too much. I have spoken an entire hour past what about an hour and 42 minutes what I was going to speak. But anyway, I guess you missed that memo, 2004L. But anyway, tomorrow I will be doing a whole bunch of Nitro V heat treat. Only 2 of those blades that I profiled and ground today are ADCR V2. The other 17 of them are Nitro V. They are all going to get a foil packet, and then they're all going to get heat treated tomorrow. So I can fit 6 to a rack. I will have 3 racks, so 3 cycles we will have to run tomorrow. I'm excited because that's 17 more blades, and only about half of them are orders. The thing is, I really like to be efficient here. Hi from Iran. Nice to see you. Is that your name, or is that your name, or what? So I like to fill out the plate with as many as I can get in there with Adventures. It's 3 wide with the foil packets. The foil packets add just a little bit of width to it, obviously. But anyway, what's up from Iran? That's a long ways away. Hope you're having a great day, buddy. All right, guys, I gotta get out of here. I'm never gonna get out of here. I'm just gonna keep on blabbing. I don't know why I do this. I appreciate all you guys watching. I love all of you. I love you, man. I love you. Hope it wasn't too boring. I appreciate all your support, guys. Have a good one, y'all.